Hello, everyone, and welcome to a new episode of Global AI Notes. And today we will talk to Ritesh and Setu about LLM Ops on Azure. Hi, Setu and Ritesh. Welcome to Global AI Notes. How are you doing today?
Oh,
Very
very well.
good.
Thank you.
You're both doing good. Oh, that is perfect. Um, can you introduce yourselves and tell us a little bit about what you're going to talk to us about today? So let's start with Setu.
Hey, so I'm Setu. I'm part of the Microsoft, what we called as field engineering team as the global black belt. So I cover Asia region and have been part of Microsoft for about 3 years. And before that, I was part of the AI MVP community as well. So good to be back.
Nice to have you back. And how about you, Ritesh?
Uh, Good morning, good evening, good afternoon, everyone, from wherever you are watching this. I'm Ritesh, and I'm a principal engineer at uh, in a group called Industry Solutions Engineering within Microsoft. And one of the main goals for me is to make sure that we are able to bring about the latest and the greatest of Gen AI to our customers, and also make sure harvest and create new reusable assets based on that from customer signals and providing feedback to the product group, and use those assets with multiple different customers to bring about scale impact.
Nice. What is the presentation today about?
So when we work with a lot of Gen AI part, right, Hank, it's easy to get started, but bringing it to production has its own set of challenges, right? And this is something that we have learned over the past few months working with various customers of how do you take an LLM app that they have developed into production? What are the right ways of setting things up? What are the right ways of doing evaluation and making it part of the process? So that's what we are going to kind of talk about today. And both me and Ritesh will kind of go into the details of that.
Perfect. I'm very curious. I know how to get started, but getting things in production is always that extra step. Like it's like always the huge step. So I'm going to give you the stage. I will add your screen share, and I will say, take it away.
Sure. So I have a few slides just to kind of set context for what we are going to present. And I know a lot of you who are joining us today have special interest in especially operationalizing large language models, or I would say language models in general. So we'll dive right into that. So just after the context, I'll hand it over to Ritesh, who will go over the steps and talk about how you can accelerate that journey going in. As I mentioned, right? Can you see my slides?
Yes, we can.
All right, perfect. So one of the key things as you working with generative AI, right? You will notice that getting started is often very easy, but you often have to integrate various applications, different frameworks, and that all of that requires specialist expertise, right? And more so specifically when you're trying to kind of operationalize that mammoth task that you have created. There are a lot of challenges that come up. You have to deal with privacy, you have to talk about security, you have to make sure that your applications are well grounded. There are a lot of techniques associated with a lot of these things, and then when we just talk about purely from a developer perspective, they might lack the necessary experience and tools to properly work with LLM Ops. This could be in terms of evaluation or scaling the solution. So having the right operating model becomes very, very important from that perspective. So why is the operating model important, right? And let me just spend a couple of minutes on this page. Uh, we always talk about being first to the market, being fast to the market, and that's very important for a lot of organizations. But when you're doing that, right, You want to make sure that you have control of your operations with secure, predictable, and flexible service delivery, right? Uh, we always talk about, oh, we need innovation, we need to get faster at development and faster in release cycle on some of these things. Essentially what the businesses are saying that they want to do it at speed, they want to be agile, and working through that, right? And with this, you have to manage, like I mentioned earlier, you have to manage your cost, you have to think about security, you have to talk about scale, and being on the public cloud, right? It's easy to get going, but then also have to make about how are you going to address this on a consistent basis while working with your application. So having working with that becomes super important. And in most organizations, right, we are working with people which have various skill sets. There are different processes from infrastructure to app dev to release to security. And again, we could be talking about various platforms itself. And that's where the work that we did on our large language models, or I would say language model ops framework that we have been developing at Microsoft on operationalizing these models in production environment in there. So just for people who are new to this idea of what is language model ops or large language model ops, it's basically the idea that comes in from a lot of these app dev and web dev methodologies called DevOps that have been adopted to the domain of LLMs. And with the help of continuous integration, which we know as CI, and continuous developments that we call CD, we aim to streamline this whole process of testing, evaluation, and then deployment of these models into production. And what we also want to make sure that, as you have seen, right, there are new models that are coming out almost on a regular basis. So when you want to integrate these models into your products, into your services, into your workflows, the whole process is seamless and efficient. And you want to maintain that high standards of quality and performance as we have been with the rest of the processes within an organization. So that's very important, that repeatability and consistency. So what we want to do with this LLM Ops is have a clear and well understood process that we facilitate the operation model, which makes sure that we are consistently and reliably deploying these LLMs, and while making sure that we are not compromising on accuracy of these LLMs as people play with these things, right? So at the end, right, it's LLM Ops is bringing together people, processes, and platforms together while making sure that we have this shared language and common set of practices to bridge that gap, right? You would have your IT teams, data science teams, and security teams. We all want to make sure that we are working together to do this at a scale and on a repeatable basis as well, right? So these are the three pillars that have seen with various customers, and we want to make sure that they are, despite the fact that they are unique in every organization, we are able to, with this LLM Ops, we are able to extract maximum value from the chosen LLM Ops application, right? So the idea is with this LLM Ops, we want to accelerate the deployments of these language models while making sure that these processes are sustainable in this rapidly evolving LLM landscapes itself. As we move on, right, and this is something that last year we have been working on ML ops part of it, and the idea was to get those same similar principles into LLM ops as well. And even with ML ops, we have seen that organizations struggle with it a bit, right? Building an app, an LLM app or a language model app, more often than not right now, it's more like a bespoke process. You have to combine models, you have a bunch of open source frameworks, you have a lot of data sources which are leveraged to make sure that your model is grounded before it answers. And a lot of these things don't scale, right? And the customers are looking for guidance on, they have these existing MLOps process. How can they be augmented to cover these new language model workflows as well, right? So as much as these generative AI introduces new techniques and new challenges, what Ritesh will share is what we have built on the existing MLOps frameworks as well, right? The ideas, concepts still remain the same. So the companies are not starting from scratch, right? So if you remember, right, when we talked about MLOps or pipelines in ML, they were very common, right? Experimentation, testing was again very common, right? So the same ideas exist in our pipelines as well for LLM Ops. And again, most of these are done by developers. And for data scientists, this was a very common idea to do this testing, experimentation, and everything. And the same concepts is what we are introducing in there. And what is critical in this new workflow is that the enterprise now have control, not only about this whole process, but how they can implement safeguards on their businesses as well, on these workflows as well, right? So Ritesh will kind of go into the deeper part of those things as well. So um, this is just my one view on AI Studio. So for again those who don't know, AI Studio is the place for all thing language models, right? You can discover small and large language models from various providers. You can build your business specific pipelines that leverages those models, and then take those models and safely and responsibly deploy this into your apps, which are part of your pipeline, and integrate them into your business application. Uh, Again, one of those features in AI Studio and ML Studio is this prompt flow, where we bring in the rigor of developing professional grade language model based pipelines. And just like your ML pipelines and experimentations, these things can be version controlled together with your prompt. And then by mixing it and integrating with your CI/CD pipeline to make sure that you have an optimal management and deployment of these things, right? So with AI Studio and Prompt Flow, you are not only collaborating with the data scientist, but also working with the data engineers and ML engineers where they do exist within the organization, and then working with them together with the app developers to make sure that integrates well and you are enhancing the overall quality of the apps, right? And then again, with Microsoft's commitment towards governance and responsible AI, which are also tools that we have integrated as part of our LLM Ops. You are making sure that these language models are not only developed in a secure and trusted way, but we are also making sure that we are adhering to the ethical guidelines and the best practices itself. Now on to my last slide, and promise this is my last slide before I hand it over to Ritesh. Um, this is a typical life cycle that you will see, right? Our journey begins with a business need that essentially propels us into the ideation exploration, right? This is where we'll formulate some hypothesis, we'll play around with the prompts, we'll play around with the models and refine our understanding of what is exactly that we are solving and how do we solve that up. Now, once we have pinpointed which language model that we are going to use, which prompt that we are going to use, now we are going to transition into the building and the augmenting phase. And this is the place where the magic happens, right? There are techniques like this retrieval augmented generation called RAG often comes into play. You are enhancing your workflow with prompt engineering. Sometimes you might be fine tuning your language models, whatever may be the case, right? As we kind of encounter these challenges, we add exception handling, and prompt flow allows for all of these things to kind of bring it all together. Now, once we have this, right, we also want to make sure that we are evaluating these models and make sure that there is a systematic assessment of these models, and the insights that we gather will inform our future iterations and making sure that the application or the workflow that we are developing is robust and aligned with our objectives as well. And as we prepare for deployment, right, our key focus is on also making sure that with the help of content filtering that we have in our AI Studio, that the quality and the safety are maintained as well. We also have rigorous monitoring systems. So that's something that we can implement as well. Managing quota and cost is also part of the overall process as well, right? And then we close the loop, right? Based on what data that we capture from monitoring, that informs our continuous improvement part of it, right? Whether it's now reverting it to a new language model or to a new prompt, whatever is the process, with the help of prompt flow, We are making sure that our processes is responsible and efficient as part of our LLM application development process. So I hope that kind of gives you a perspective of the need of LLM Ops and how does AI Studio and Prompt Flow play a part in there. Over to you, Ritesh. Hank, if there are any questions, happy to take it now or towards the end of the our session.
Oh, great. Thanks a lot. Thanks a lot, Seru. That was quite insightful about LLM Ops. And now I think we'll get into the thick and thin of it as to what LLM Ops is all about. So as you saw, what Setu mentioned was there are two very distinct phases. If you try to distill them out, is that we have an inner loop and an outer loop, and obviously LLM Ops is an evaluation is an evolution from DevOps and MLOps and has best of both DevOps and MLOps bringing together. So when we look at LLM Ops, we see various different scenarios because you might have a scenario where you want to do prompt engineering. You might have another scenario where you might also want to do fine tuning of an existing model and then deploy that model and then use it along with prompt engineering. You might have a third scenario where you want to do implement uh, a solution consisting of your own documents, which are not generally available with large language model. In that case, you might implement something called a retrieval augmented generation or a RAG pattern, along with fine-tuned model and prompt engineering on top of it. So you see there are multiple different ways you can combine these various different facets of a application comprising of large language models. And so when we're talking of LLM ops, we bring all of these things together, depending on what we are planning to do for the current application or solution, and then them through various different phases of inner loop and outer loop. So when you think about inner loop, it's very similar to MLOps because we want to do experimentation if it's a prompt engineering because we want to experiment with different prompts or and then evaluate them, or and you might want to do fine tuning of an existing model, which is very similar to an MLOps, as we traditionally have been doing, is to take an existing model, load the model, and fine tune some of its weights, and then after training, evaluate those model as well, and then eventually go for an outer loop. So inner loop generally consists of training, pre-training, and obviously experimentation, and obviously along with that is the evaluation bits. Once you have done this and you're happy with the results of your evaluation, you move from inner loop to the outer loop where you deploy the solution, your large language model. It could be an endpoint, it could be a model, and or it could be both. And then once you deploy this, you want to consume it for an inferencing purpose to your customers. So you want to provide those endpoints to your customers. And if it's a model, the endpoint uses a model behind the scenes. So you want to provide those as an endpoint. So you deploy them and then you start monitoring. So all of those things were covered by Setu. I just added some more details to it as to how various different components comes together and helps you build for LLM Ops. LLM Ops is not the end goal. The end goal is to have an app on the production. And how do we do that in a consistent, predictable, and a faster and a cheaper way is in a long term is what LLM Ops is all about. So one of the main tools from Studio AI Studio as well is actually called Promflow. And as you can see here, we have AI Studio over here. And those AI Studio, when you actually launch the AI Studio, you get a complete suite of services, which comprises of Promflow, which is an orchestration tool to bring about your logic and incorporate large language models into it. So think of it like this, that this takes an input, processes a set of steps, which becomes your primary logic, and then generates an output to revert it back. You could deploy this entire prompt flow that you're seeing right now as an endpoint. And so that endpoint will always expect an input, will do all the necessary processing and generate an output. While you do that, you have the possibility to include whatever you want as part of logic using Python tools. Plus, you can also bring your prompts. And when you bring your prompts, this is a default uh, scaffolding template that I'm showing you from Promptflow. When you bring about your prompts, you can have the concept of something called variants. And variants are like something, if you generate a prompt, Generally, you want to have multiple different types of prompts, because you might say, okay, this prompt works better than other prompts. So you want to store those prompts, first of all, version those prompts. Plus, you want to test and experiment which prompt is working better for your solution, because a prompt might give you a better answer from large language model compared to the other prompts. So when you're looking at this kind of a solution, then Promptflow is the best to help you deploy, plus experiment and evaluate them. While we can do experimentation, evaluation, and deploy all from the UI, the primary purpose when we want to do it on production is not the UI. Though we want to do some experimentation initially from the UI, but we want to use a consistent and more predictable manner rather than using ClickOps to go to production. And that is where LLM Ops helps us to do with the prompt flow. So one of the template, or one of the assets that we have, is called LLM Ops with prompt flow. And this asset is available freely, and you can, obviously we will share this link with you, and you would be able to clone this, fork it, and make sure that you're able to use it as well. But this is meant for prompt flow, which means if you're doing prompt engineering, if you're calling a large language model, the large language model could be something from a model catalog within Azure. It could be a large language model from Azure OpenAI, or it could be your own model somewhere on a VM in your system. You would be able to call any of those models from prompt flow, and this template will help you do so. This template provides you with all the necessary features, which I will go through a bit later. But the primary thing that you want to understand here is what are the process flow for the large language model over here with prompt flow. So this template comes up with, and we'll go into those details, but what it helps us do is it provides you with few pipelines, and those pipelines are integrated with prompt flow. And so, for example, as you can see here, we have you generally have a feature branch. On a feature branch, you develop your flows, and the flows are, as I just showed you on the prompt flow, consists of input, it has an output, and has a complete logic in between as an orchestration steps. And once you go through them, you in a feature branch, once you have developed them, and that's the core of the logic, that where you want to spend your time. You don't want to spend time on how to do experimentation. That should be given to you. You should know how to bring experimentation and evaluation together, but that is not where you want to concentrate. You want to concentrate how you want to build your logic and how you want to evaluate your logic, right? So for example, if I build a simple flow like this, and this I'm showing from a machine learning studio, I should be able to quickly evaluate it, because I want to figure out how good my system is working. If I say, for example, I'm trying to uh, generate, for example, a solution with math, which I will show you math related problems. I want to say, please find the square of 7 for me. Is it giving you 49 or not? How accurate it is, whether how relevant it is, how groundedness it is, and how whether you can really trust that output or not, whether it contains things which you don't want to see. All of this you want to test it. And for testing them, you need to write evaluation flows. So we have both evaluation flows as well as uh, standard flows. So when you say I want to create a new flow in prompt flow, and you can say there's an evaluation flow, there's a standard flow with some templates. So you can pick and choose. You need to generally bring the standard flow and the evaluation flow together, because once you have a standard flow, you want to evaluate them, and then once you're happy with them, you want to deploy them. And as you can see here, when you create a feature branch, you have both your standard flow and the evaluation flow. You want to set up the environment. You want to test all the Python code that you have written, code quality, unit testing, making sure that they all work well with the data that you already have. And then after you're happy with this, when you do a PR, you do the validation, and when you try to merge that PR to your another branch, which in generally is a dev branch or a development branch, you want to make sure you again test those things from a quality perspective that you did in the PI pipeline. The difference between these two tests is that the PI pipeline should be quick, because you want to test those things, the code, on a smaller set of data. Whereas for the CI pipeline, it could be a full set of data, or maybe a larger sample of data, depending on how much data you're playing with or the volume of data you have with. Once you have executed your code quality test within your CI pipeline, you also want to make sure you execute experimentation with different variants that you have, with all the data sets that you have, and evaluate them and find out which variant, which data set, which flows are working good for you, and depending on the report that it generates, you find out the best solution for that, and then you go for a deployment, which is the CD pipeline. Over there, once you do the deployment could be now into various different places. You could do a deployment to Kubernetes, or you could do a deployment to Azure Machine Learning, or within the Studio AI itself by providing an endpoint. And endpoint's nothing about like a REST APIs that you can call by sending inputs, and it will just generate an output for you. And by after executing all the orchestration steps, or you could actually generate a Docker image, bake in all the flows and the necessary components that you need to make it happen, and then deploy that and use that Docker image to run as a container, either on a function app or on Azure App Services, or you can even take it to Kubernetes, or you can just deploy this on premises wherever you want, because this is a Docker image. You would be able to self-sufficient image, which you'll be able to run as a container, um, almost all platforms wherever Docker is supported. And once you're happy with that, then you can go for production, or you can add more environments to it. So this is the overall flow. But what are the main, I just touched upon briefly, what are the main components that you need to bake it within a Docker image if you have to do so, because it has to be self-contained. So a flow, when you look at it, a flow consists of the files that you see over here. So they should be part of the Docker image, right? And these files, as you can see here, like for example, if I'm using a prompt, that prompt needs to be sent to a large language model. How do I send it to a large language model? I need a connection for that. Like that large language model could be a GPT-4 within Azure OpenAI, or it could be Open Azure, or just an OpenAI, or it could be a model deployed using your model catalog. So there's an API for this, and you need a connection for that. So you need to create a connection, right? There's a default connection, but if you want, you can just quickly create a new connection. You can come back to your AI Studio and say, I want to create a new connection, and just click on the new connection and provide all the necessary details about what's your key, what's your API base, what's your version, and what's the name. And that is then available over here to you for use. And once you say, I want to use this, you need to configure it. Like what's the temperature? And these are generally the parameters that you need to configure for using a large language model. They, to a very large extent, determine the output that you will get from a large language model. So how many tokens you want to use, and what's the response formats, and whether you want to do function calling, what's your prompt, and you can generate some variants, right? So you can say, I have this one variant, I have two variants in this case. So all of those things, you can do it over here. So these connections, very important, needs to be baked in as part of your Docker image, so that you will be, when you run a container, you're self-sufficient. You know how to connect to OpenAI or Azure OpenAI, or whichever model you're using for that matter. And I'll show you how that happens as well. So after you create a connection, the next thing that you need is a runtime. Where do you run this? Like, who understands these files? Who will be able to execute your flow.meta.yaml, which is primarily the orchestration code, which brings all of these things together? Who will do that? That's the job of runtime. So when you are trying to execute this, it's the runtime which is responsible for making sure you get all the support from bits and binaries, and you're able to execute this end to end. So there are two types of runtime. One is an automatic runtime that you see here, which is a serverless runtime. So you don't need to create any physical compute. You don't need to create any VMs, nothing you need to do. You just say, I want to use this automatic runtime, which will spin up a physical box for you, or a VM for you in the background. So, and it will also install the latest runtime on top of it, so that when you want to execute this or want to run this, you don't have to, you can just run it automatically. The other runtime is where you have to build your own physical box, and then you have to make sure that physical box is assigned a runtime, and you have to do a lot of steps to make sure you're able to do that, and then run. Eventually the output is same, because this is automatic serverless, and that's where you have to do the steps manually or automated steps, but you have to do that on your own. So once we understand these things, now we know that we can go to production and do all of those steps. So as I was just talking about, we have an asset called LLMOps from template, which supports both GitHub as well as Azure pipeline. So if you want to use Azure DevOps, you can do so. If you want to use GitHub, you can do so. And there is no feature differences between them. They both support the same features, almost everything. And depending on your choice, you could use any of them. And this template also comes up with 3 different examples. And these examples are part of actual prompt flow examples. So we are just ported here to show you how to do that, everything. which means if you have three different use cases over here, which means you can use this template to host or to go to production for as many as use cases as you want. So one of the use cases could be my customer chat application. The other use case could be HR for my company documents and providing support to my internal employees. The third could be your if depending on the choice of depending on your company, it could be something related to your business and things like that. So you don't need to deploy this solution again and again for each use case. You can use one template, one deployment, and you can have as many use cases as possible so that you can just focus on the use case and rest everything comes together over here. But then how does it work? The way it works is that I'll take you through the Visual Studio. I just cloned it. The way it works is that every use case has a set of configuration, has a set of folder structure which you need to manage and maintain so that the platform understands it. And the entire platform code is within the LLM Ops folder, which understands how to read which use case and which file and which data, which configuration, and how to configure the deployments and everything together. So let's go through that. But before we go through that, we should understand that what is an end output of it. So I will show you an example over here. So this is an end-to-end solution where when you use this large language model operations template, this is a final output I get. How did I got this output? I had a set of I have a use case called math coding, which is what you're seeing here live. And this math coding has a set of folders. So the important folder is the flows, the first important folder. And it has both the standard and the evaluation flows. If we recall in the beginning, I mentioned that prompt flow provides you with both the standard and the evaluation flow. So standard flow is nothing again with the same set of files that you generally see you were seeing over here, right? When you come here, you see all those files over here is what the standard flow is comprises of. Similarly, the evaluation flow also comprises of similar files, but the logic is obviously different. It's again the input, output, and the orchestration flow over here. So once we have these two flows, and this is where you will spend the major time building them, because this is what the template does not understand. This is what your use cases, this is what you need to solve as a business problem. Once you've brought these files or these folders into the flows within this use case, the next thing that you need to think about is the data. I need data because what problem I'm trying to solve here? The problem I'm trying to solve here is that I will give you a mathematical problem and you need to give me an answer. So like, for example, what is the square of 7? The answer is 49. And it also gives you the Python code as to if you have to execute this code, what should be the answer. So if you gives you print 7 double asterisk 2, which means it will print 49 for you. So I need data. So I have a data over here. So with some sample data, which you should be already having it. If you don't have it, then you should use something like a synthetic data generator to generate them so that you have data in this format. So you have the query, you have the answer because you want to do experimentation. And how do you do experimentation? You do experimentation by running this query, generate an output. And then when you evaluate, you compare the output from this query with the answer and you see whether they match or not, for example. And this is obviously different for each use case. In a math problem, I can do this. For a RAG scenario or a retrieval augmented generation scenario, I might not compare the answers like the way I will compare here, like 8 versus 8. I will maybe do a cosine similarity. Say, this is the output from the query, and how similar is the output answer that I'm comparing with. So if it's more than 95%, then that's the thing that I'm looking for. But if it is, say, less than 95%, then maybe I need to do some more experimentation. So this is completely use case dependent, and this is just one use case I'm showing you. I can have multiple test data. And so once I have the flows, I have the data, which is what you have to bring from your use case. Then we need to go to the configs. Within the configs, we have one of the important configs is the data config. Here you say, I have two different files. Which file I want to use for my PR pipeline, for PR data. You could have one more file which says a small set of data which is for use for PR. Then there is something I want to use this file for my experimentation, and I want to use this file for my evaluation. And that is what you need to bring here. So this is used for my experimentation, evaluation, and we store this data within data assets within Studio AI and Azure Machine Learning Workspace. So what name should be part of that data set? and what's the description and what's the purpose of the data. And once you just configure this, automatically these files will be picked up by the large language model. They will be registered within the Azure machine learning and will also be used for experimentation and evaluation purpose. So you don't have to do anything. The only thing you need to do is to make sure configure it well so that you use the right data with the right flow and that you need for. Once you have the data, then you also think about, okay, now I've done for experimentation and evaluation. How about deployment? I can have configuration for my deployment as well. So you don't need to do anything for the deployment. The only thing you need to do is configure your deployment options. I want to deploy in Azure as an Azure managed endpoint. Then I need to provide some information as to what's my endpoint name, what's my deployment name, how I want to deploy. If I want to test after my deployment within after Azure machine learning endpoint, how should I test it? So I need to provide some sample data, and that sample request file is also available within each use case. So you can say my math question is, what is the square root of 30? In this case, I want to test after deployment within my pipelines itself. And so all of these configuration, I'm not going into the details of each of them, but one of the things I wanted to show here eventually was that it also supports A/B deployment, which I will show you as an example. To do a deployment to Kubernetes endpoint as a attached to Azure Machine Learning Workspace, you can also deploy to web app endpoint. And for web app endpoint, basically what you do is we generate a Docker image, and that Docker image is deployed as an endpoint within an app services within Azure. But then the scope is unlimited once you have a Docker image, because you can take it anywhere, as I said, in function apps or Azure container services and things like that as well. So these are the configurations you need to do. And you need to also provide your Azure DevOps pipeline. And these pipelines do nothing. The only thing that they do is actually hand over the request to a platform CI dev pipeline, which is there globally available over here. So the bulk of the logic of the entire experimentation, evaluation, approvals, deployments is there within this platform CI. The only thing that you need to do here is to invoke them with your own parameters. So whenever there's a change in the code or files within this folder, then only the pipelines related to math coding are executed, because you can have multiple use cases. For one change in one math coding, you don't want to execute your pipelines for web classification or for named entity. And that's the reason this kind of a structure has been created. So you just have to have, this is like a wrapper on the platform CI and CD for you. Similarly, the wrapper for PR as well. And the same concept applies for GitHub as well. So, but the GitHub pipelines needs to be within the workflows folder within on the top level. They cannot be in the nested folders. So all the workflows for GitHub are generally there in one place. That's the only difference. So once you start executing this, how does it look like? So what I did, so this is my original template. What I did a fork. I brought it to my own personal. So this is from Microsoft LLM Ops template. I forked it to my own GitHub repo. So I have, this is my GitHub, and this is a repo that I have forked it, which is no different than what it is there from the Microsoft one. And then I cloned it based on the steps that have been mentioned over here. So there's a steps mentioned for GitHub as well as Azure DevOps, all the documentation over here. So what you do is go through the step by step. If you want to use serverless runtime, there are steps to mentioned over here that if you want to use for serverless runtime, if you want to use physical, then use these steps. But towards the end of it, it will tell you that if you want to use serverless runtime, then you can do that as well. So this template supports dedicated compute instance in runtime by default. And then you can switch on the automatic runtime by doing some minimal code changes here. And those are mentioned here, how to do that as well. Then you set up your GitHub repo, which means you actually create a fork. I was just mentioning that. Create a new dev branch, because that's what becomes your main branch. You don't want to do changes to your main branch, which goes to, or release branch that goes to production. You, from a feature branch, you want to come to your development branch. So you do that. And then you enable, obviously, you make it a default branch. Your dev branch becomes your default branch. You enable your actions within Azure DevOps and within GitHub. You set up some secrets which are needed, because we need to connect to Azure, for example. How do we do that? You need to provide all those secrets over here. It works with the concept of service principles. But then how do we first of all reach to Azure? Because these are secrets that I will use it. But then this does not tell me which tenant, it does not tell me which workspace I want to use, for example, which key vault I want to use, and all of those kind of things. And that's where within each of the use case, you have the LLM Ops config. So I define all my environments over here. I have two environments in this case, the PR and the dev. If I want to add production, I just have to replicate this with my own configuration. And here I provide what's my environment name, what's my resource group name, what's my workspace, which is my standard flow, which is my evaluation flow. You can have multiple evaluation flows for each standard flow because you want to evaluate different things within for a standard flow. For example, in name classification, you would see here that we have two standard evaluation flows for one flow, standard flow. So you could do all of those kind of things. So you need to configure this file as well, which is the main config file, and then do these adds or secrets. So you want to set up some connections from Runflow. So when you do evaluation or experimentation within your pipelines, you need to connect to large language model. You want to connect to so that you can experiment. So you need to set some connection parameters to it. Now this is different than the Docker because this you do it in the Azure pipelines. For a Docker, there's no Azure pipelines or there's no GitHub pipelines or workflows. You can take that image anywhere. So that image needs to be self-sufficient, and that's why you bake in those connections within your Docker image as well. Obviously, you need to create some connections and all of those kind of things. And you need to provide your details about a registry within as a variables. And then once you've forked it, you clone it locally. And this is the clone repo to my environment. So if you see here, it says github.com Ritesh Modi LLM Ops from clone. It does not go to Microsoft because this is where I want to do my stuff. And then what I did was I did a series of PRs onto it, and I'll just show you what kind of PRs I did. Very simple PRs. The first PR I did was to use it after I forked and cloned and did some configuration on the GitHub side of things by adding some variables, making sure I'm using the right runtime. What I did was since I wanted to use serverless runtime, I did some small changes like which you can obviously read through the documentation, like what should be the size of my serverless runtime, because I have to just say which compute size. I don't have to create a compute, but behind the scenes, it will use this size to create a compute. And then I don't want to use a runtime, so I just comment that because it's an automatic runtime. Those are the changes I need to do to 3 different places. And then I need to say, okay, I want to use my deployment config says I want to use this registry. I want to use, this should be my math coding plan name, this should be my web app name, and this should be my SKU, and I need to configure. So it's all configuration. There's no code, as you can see. And then I need to say, from my LLM Ops config perspective, which key vault, which resource group, which workspace I want to use. For my deployment config, if I want to use any other, I have changes done to both 3 of the use cases in together. So if it's just one use case, and that's about the changes you need to do. So those are the changes I need to do. And once I execute them, as you can see here, once I go to my actions in that case, you would see that the first one is my PR pipeline. So I'll take you directly through to the merge that happens here. So as you can see here, we did experimentation and evaluation. So we did the login to Azure, we configured agent because we need to download the prompt flow, binaries, SDKs, and all of those kind of things. We can do everything with prompt flow. And then we register our experiment data asset. As I talked to you before, we have a data within a local folder, and then you want to register them. But it will register and create a new version only if there's a change in data. Otherwise, it will not do that. So it's quite intelligent in that matter. And then it will run the bulk flow. So for example, in this case, you had 20 questions, right? So you will take each question from this data asset for experimentation, and then execute complete the entire flow one after another. So you will have 20 different answers over here. So the one that I'm showing you right now is for web classification. So let me show you for math coding. So we should have something on math coding over here, and you would see the same thing. So when you execute the bulk run, you would see that there are 20 questions, one after it's showing the top 10, but what is the sum of 5 and 3 and all of those kind of things. So you did an experimentation. You will pick up all the runs, and then it will register the evaluation data and then run an evaluation on the answers that you got from the experimentation, because you also have the expected answer and the actual answer. Now you can run your evaluations, and once you've done the evaluation, it will archive it and it will complete the inner loop part of it. Some advanced use cases, in this case, there was just one variant, so there was not much problem. But in case you have multiple variants, then it can become quite complex. And as you saw in web classification, can have multiple evaluation flows because you want to evaluate multiple things. So as you can see here, we had in web classification, for example, we have two evaluation flows, evaluation and evaluation advanced. For each evaluation, we had two different data assets. So we had data assets which are different. And for each data asset had 3 rows. And for each row, for each of them, we had two variants, variant 0 and 1. So the entire combination of these flows, data assets, and the variants is executed automatically for you. You don't have to do anything. You may have 20 variants, you may have 20 data assets, you might have 5 flows. They all will be combined automatically for you to provide you and say which combination between them, like you have accuracy and precision, two different matrix over here, which of them provides you with the best answer. In this case, variant 1 and 0 had no difference. You can pick any one of them, which any data set, and then you could pick and choose and deploy that variant automatically for you. So being said that, the next step is the deployment. And that deployment, again, make sure that you register the flow as a model within Azure because you want to version it, you want to make track of it. And once you do that, you want to deploy to, depending on the choice that you have chose, you want to deploy to AML or you want to deploy to Kubernetes. If not, in this case, we create local PF connections for the Docker image. If you remember, I mentioned that. And then we create a Docker image and push that image to an ACR as well. All happens automatically within this step over here. As you can see here, quite a few things going. I will not go into the details, but you created a connection and then within deploy to web app, the topmost level things that you would notice over here is that we generate a Docker image, first of all. So we download the base image, we resolve it, we create a new image, we include all the dependencies and things like that, make connections, and then push it to ACR. If you go towards the download side of things, then you will see that we are pushing everything to ACR over here. And then making sure we create a web app. That web app is configured for downloading the image from ACR and run a container, configure everything over there and run it as well. So let me show you that. So if you come to this is what got generated and app service as part of the entire flow. And once you do that, you will see that all the environmental configurations related to where the Docker registry is, what's the username, password. AOAI is nothing but my connection to my OpenAI. They all got configured automatically, and then you're able to run this. So if I pick up another question from here, for example, solve for X, this one, and I'm expecting 3 as an answer, then I can obviously now have deployed this. I can run this over here, and this should give me an answer, whatever it is, depending on my experimentation, that the answer is 3, and this is how you should get it done. Now, being said that, we can also test this entire thing from after you do a deployment. In this case, this is a named entity recognition, another use case that you have it over here locally available. As you can see here, same thing, but we can test it using a sample request. For example, if I take this and we say, okay, let's do a JSON. And we say, okay, the text is Maxim is a data scientist at Auto Dataset, and his wife is a finance manager in the same company. Get me all the job titles. So I can obviously do a test on this, and it will give me data scientist and finance manager. The beauty about this use case is that it has 2 different deployments, which means I can do A/B deployments, blue-green deployments, where 80% of the traffic is going to one and the 20% is going to the other. And this was also configured for named entity recognition using my deployment config. You don't have to do anything. I have mentioned here that my prior deployment, the first I need to do one deployment, which is my blue deployment. Once I do blue deployment with 100% allocation, and then next day or maybe next week or next month, whenever I have a new deployment, I say my prior deployment is blue because that becomes your prior, and the new deployment is a green. And I say the previous one give 80% traffic. I want to test the new deployment. I don't know how good it is because I've changed my prompts and things like that. Just give 20% of the traffic to it and see whether it works well. If it works well, later then I want to convert green to 100% and make it 0 for the prior deployment, in which case they will be just one deployment. And that's how this has been generated as well. And then you can say, I want to test. And this, all the tests that you see here happens within the pipeline itself. So as one of the final steps that you will see here, once you deploy, is also that the test happens within the pipeline. So you can do the test after deployment. And this happens both for Azure DevOps and as well as for GitHub. One of the things I just wanted to show you was when you run a pipeline, let's say in Azure DevOps, you can say how you want to deploy, right? So you can say AML, AKS web app. So if you choose AML, it will go for an AML deployment, which will be a separate steps compared to web app. If you do web app, then it will generate Docker. In case of AML, it will not generate Docker. So those are the things that happens within the pipeline. So I covered experimentation, evaluation. I also covered deployment. I covered Azure DevOps a bit. I covered GitHub more extensively. And I talked about how everything comes together, the data assets, how flows come together, how you do experimentation, and then how do you deployment, and various different places, how you do A/B testing and A/B deployments as well. And then eventually, the thing is you will do monitoring, configure the monitoring as part of LLM Ops. You will capture those data. That becomes again an input part of your pipelines. And that process is an iterative continuous flow that will keep on happening. So whenever you want to bring about changes, you do changes to your code, do a PR, when a feature branch, goes to dev, goes to production, and then everything is there, should be in place. For Azure DevOps, we also provide manual approvals so that if in case you want to manually switch to CD or go to CD, then you can do that as well. The links we will be providing you, this is the main link of LLMOps prompt flow template. This is the link from Microsoft documentation. And obviously this documentation talks about how to do everything. So please go through this GitHub and Azure DevOps pipeline. They are both documented over here. And they will eventually give you the links to the actual template. So we'll share both the links with you as well. I think that's what I wanted to cover. So I hope that should be okay for introducing LLMOps with prompt flow to everyone.
Yeah, Ritesh, pretty exciting, right? Every time I hear this, it's good to see what we have come up with. So, do you want to share also what are some of the new features that you are going to bring up in LLM Ops as well? I think that's also pretty exciting for a lot of folks.
Yeah, so that's a good one. Thanks, Setu, for reminding me that. So there are a few things we are bringing over here. One of the important things is that right now what you can do is public infrastructure. So when you want to do everything on public infrastructure, no problems, you can do that. But we are going to add very soon the infrastructure for as code for private networks as well. So you would be able to create your own managed VNets and everything. Everything will happen internally within your VNets, not exposed to the outer world. So that's another important thing that's coming up. Second thing that's coming is data ops, very, very important, because right now what you see is files within your folder structure, but those files and being and data assets, how do you get those files in place? We're coming up with data ops where you can do some pre-processing, post-processing, reading actual data from various different sources, and then bringing it in a shape and putting them into a data asset as well. You would be also be able to execute prompt flow pipelines from here, from your AML pipeline. So AML, or we have the traditional ML ops, the Azure pipelines within Azure Machine Learning Workspace. You'll be able to trigger the pipelines over there. We have an example, new example getting added for a RAG or a chat with PDF. And a major important thing also, another example is to use agents within your pipeline. So if you want to use agents within a prompt flow, how to do that, and then how to use LLM ops along with that. So all of those things we're working on right now, and they all will be added as part of this template as well.
Yep. And as Ritesh mentioned, all of this is open source on GitHub. You can see the link on the chat. So again, if you have a feature request, I guess Ritesh, people can contribute back as well, right?
Yeah, this is a public repo. Anybody has any feature request, any demand, you find a bug, issue, please do let us know. More than happy to help you out in that.
Sure. That's great, Ritesh. So last thing that we wanted to cover, I will share the link for the maturity level that we did on LLM Ops as well. So this shows, right, hey, where you are in your LLM Ops journey as well, right? Most of the organizations are somewhere between 1 and 2, where they're playing around with models, playing around with prompts. They're doing some sort of prompt engineering with RAG, and most of them do have some sort of structured deployment in which they work with these LLM or language model based apps as well, right? And the idea for us to bring off this accelerator was to kind of speed up your journey from your initial or defined phase to all the way up to optimized, where Ritesh talked about, how you can have a CI/CD process, whether it's fully automated or fully or partially manual with approvals and everything. And as you work with your online endpoints, you have monitoring and controls that are built in there. And then, of course, you kind of take the output that's coming in from your monitoring to go back and refine, which model that you want to work with or optimize on your prompt as well. So there are a lot of these ideas that you can certainly work with, and our goal of sharing this with the community was to help them help organization accelerate their maturity from just a basic LLM based apps to an optimized flow where most of these things are automated and controlled in a very structured and organized manner. So that's all we have for today as well. And if there are other comments that you have, we'll be happy to take that up as well.
Thank you for that presentation. That was a lot of information in an hour. Someone is asking if we can share the link with a roadmap as well in the chat.
Yeah, I think what we'll do is we can share the link of all the PRs and the roadmap. We are building the roadmap for this, so once we have that, we can share that link as well. But right now, we can share the link for the PRs that we have in plan.
Perfect. Then that was it for the questions. I will share the links. I will add them to the description of the video. And then I want to thank you both so much for joining the Global AI Note Show. It was great to have you all. Thank you very much.
Yep. Thanks a lot, Hank, for inviting
Thanks,
us.
Hank.
It was great.
Pleasure to be here.
Thank you. Bye-bye.
Bye-bye.